Let's find behavior. So what are we looking at there? What do we have that tells us the end behavior? You look at this first term, you know that n is, if it helps you to write it down, you can write it down. N is odd, the exponent is odd, and a is positive. What does that tell me?
Up, down, left, rises.
Think of it, if it's positive, it's going to eventually increase. So I think of a line, it's going to, positive means it's going to point up at the end. So what's it doing on the left side? It's down. So it falls to the left. And it rises to the right. So you write that down first. Find each of these first, and then we're going to go back and graph it. These are each important to the graph. So then we find the x-intercepts, or the zeros. How do I find the x-intercept? How do I find an x-intercept? Put in 0 for y, which means equal to 0, right? How do I find the zeros? I said equal to 0. To solve this, I have to factor by grouping, because there's 4 terms. So I'm going to do x squared, x plus 1, and then minus 4 times x plus 1. X squared minus 4 times x plus 1. Still equal to 0. Make sure you bring that down. So now I set each of those equal to 0. X squared minus 4 equal to 0 gives me x squared equals 4. Take the square root. What do I have to do when I take the square root? Plus or minus. So we get plus or minus 2. X plus 1 equals 0 gives me x equals negative 1. In addition to writing those down, you need to also write down what's going to happen at each of those zeros. So how many zeros do we have there? 3. Do any of them have a multiplicity? No. So their multiplicity is technically 1. We don't really write that down though, but you need to think that in your head because 1 is odd. What are each of these going to do? At negative 2, what's it going to do? It's going to cross. Negative 2, it crosses. At positive 2, it's going to cross. At negative 1, it's going to cross. Because it's an odd multiplicity, it's going to cross at all those points. That's going to be super important when we go to graph it. Alright, y-intercept. How do I find the y-intercept? Plug in 0 for x. 0 cubed plus 0 squared minus 4 times 0 minus 4. I think some of you could have told me what it is before. What's the y-intercept?
Negative 4.
Negative 4 is the only thing left there after I put all those zeros in.
So wasn't the cheap ideally just use C? Or was that right?
Just be careful. It depends on how these ones are set up.
Mr. Russell, what does that say in the red? 2 what? Zeros.
The zeros are negative 2 and it crosses, positive 2 and it crosses, negative 1 and it crosses. Trying to find a decent green here. Alright, symmetry. Symmetry, you have to decide if it's even or odd. You can't read that at all. That's your question in your head. How do I decide if a function's even or odd? What do I have to do? You have to plug in negative x and see what happens. So I'm plugging negative x into that original equation. And seeing what happens to the signs here. That's really what you're checking for. So I get negative x cubed. That's going to become negative. This is just going to stay plus x squared plus 4x minus 4. What do you notice when you compare that to the original? Did everything change? Some things changed, some things didn't, so this is neither. When you have neither, that means there's no symmetry. And then the last thing we're doing is just so when we graph it, when we look at it, we can figure out how many turns it's supposed to have. The number of turns you use the formula n minus 1. N is your highest degree. What's my highest degree? 3. What's 3 minus 1? 2. It's going to have 2 turns max. A maximum of 2 turns. That's the equation. N minus 1 will give you the number of turns. I am now. So to graph it, we're putting all this together. Step 1 is graph the intercepts. Graph the x-intercepts, graph the y-intercept, put those all on the graph. So our x-intercepts were -2, -1, and +2. Ooh. -2, -1, +2. Our y-intercept was -4, right? So you put all those down. Those are points that the graph has to hit now. Your second step is to sketch the graph, but you have to look at some things here when you sketch the graph. The first thing you want to look at is your end behavior. Your end behavior is going to tell you what direction to point the graph, whether it should be pointing up or down on the left and whether it should be pointing up or down on the right. You also have to consider whether it's going to bounce or cross at each of the intercepts. So as you go to graph it, if it says bounce, it's got to bounce off that intercept. If it says cross, it's going to go through that. And then the last thing you have to consider is the number of turns. You can't go over that number of turns. That's just kind of giving you a limit so you don't get crazy and give me like something that has 1,000 turns in it. That's your limit. So right now, what do we know about the end behavior of this graph? It's pointing down on the left, right? And then up on the right. So on this side, it's got to be pointing down. But on this side, it's going to end up pointing up. And each of the intercepts, it's supposed to go through them. So we want to go through. So you kind of see we have to start down here on the left-hand side. It's going to go through, and then it's got to come back and go through this, and it's got to go through this point, and then it's got to go through that point, and it's going to point up. You have to put all of that together to get what these are going to look like. Yeah, this is going to be yucky on here, but bear with me. Something like that. All of ours aren't going to look exactly the same, but I should see it going through the points when you say it's going to go through the points. Or I can make it a little bit thicker. But do you see it has the end behavior that we said it's supposed to have? Does that make sense? Alright, so we decided because it's even and it's positive, it's going to rise on both, right? Rises to left, rises to right. How do I find the x-intercepts? Equal it to 0. It's like finding the zeros. This is where you got to remember a little something from chapter 1.
The u squared thing?
This is a u problem because it's to the 4th power. You can't factor things to the 4th power, and there's nothing. If there were an x squared in all of them, we could take it out, but is there an x squared in all of them? No. So you have to do the u substitution here. This is going to be u equals x squared. So this turns into u squared minus 4u plus 4, and now we can factor that. Factors of 4 that add to -4. -2 and -2 to get positive 4. They're both negative. U minus 2, u minus 2. So we're going to get x squared minus 2 times x squared minus 2. So I only need to solve one of those, right?
Yeah.
X squared minus 2 equals 0. X squared equals 2, and take the square root. In the back of the book, they're probably going to leave it as a radical, but for the point of graphing it, I'm going to make it a decimal. So it's plus or minus 1.4. So we have 2 zeros there, right? Positive 1.4 and negative 1.4. The question is, what's the multiplicity of these?
2.
Look at your two factors there. Look at these.
It's 2.
Aren't there two of those same factors? So isn't this one on the left, isn't that going to give me 1.4 and negative 1.4? And isn't the one on the right going to give me 1.4 and negative 1.4? So how many times does 1.4 happen?
4.
How many times does positive 1.4 happen?
2.
2. And how many times does negative 1.4 happen?
2.
2. Because I should have a total of
4.
4. So these both have a multiplicity of 2. What does that tell me?
That means it bounces.
That means it's going to bounce. So this is going to be an example of what a graph looks like when it bounces. Y-intercept? Plug in 0 for the x's. So the only thing left is that plus 4 at the end, right? So we get 4.
What's an example in C wouldn't work?
Like if it's in a factored form, C wouldn't work. So if it's in some other weird form. Symmetry. What did we decide we have to do to find the symmetry? You gotta plug in negative x. So it's negative x to the 4th minus 4 times negative x squared plus 4. What happens when I take negative x to the 4th power?
Positive.
Positive. And then make sure in this next one you think first, what does the squared do? Makes it positive, but then that minus 4 is going to stay minus 4, isn't it? So it's minus 4x squared plus 4, so it doesn't change. What does that tell me about this function? It's even. Even means that it's symmetric with the y-axis. Our y-axis is going to be the symmetry. If it's odd, it's symmetric with the origin. So that's how I remember odd and origin go together. They both start with O. If it's even, it's with the y-axis. How many turns is this going to have? Maximum number of turns? 4 minus 1.
Oh, 3.
So 4 is the degree. It's the degree minus 1. N equals degree. So you do the degree minus 1. You get 3 turns max. At maximum, you can put 3 turns in this graph and get the correct answer. So far, so good? All right, let's graph it. So to graph it, we have to put the intercepts down right now. They're decimals, so you're going to go in between. So on the graph, we go between negative 1 and 0, and between between negative 1 and negative 2, and between positive 1 and positive 2. And then the y-intercept was positive 4, right? So that should be the easy part of graphing. The next part is you kind of have to visualize it in your head before you write anything down here. You have to think about, what did the end behavior tell me? They're both going to be pointing up, right? So if that helps next to the end behavior to say, oh, what I know about that is they're both pointing up. It's going to point up on both sides if you want to draw a little picture to yourself. Sorry that this is getting all tilted. But they're both going to point up. So it's got to be pointing up on this side, pointing up on this side. So I'm starting up here to graph it. I have to go to this point. What did we say is going to happen at this x-intercept? It's going to bounce. So it's going to touch it and bounce back up. And then we got to go through this point. And then we got to get to this point. And it's got to touch it and bounce back up. And then it's got to end pointing up. The one other thing you have to think about is the symmetry. What did we say about the symmetry? It's symmetric with the y-axis, which means whatever you do on the left side of the y-axis, it should match on the right side of the y-axis. So you just want to kind of try and make it look similar. You don't want it to be off balance. So here we go. This is what I would, no, that's not great. I'll make it work.
It's a W.
It's kind of a W shape there. And if you're not 100% sure, you can put these in your calculator to get a better look at it. But that's what it should look like, because if you notice here, if I put a dotted line down the center here, do you see the symmetry? They should match. You shouldn't have like this and then it gets like way bigger over here. You should try and keep them the same on both sides when we know that symmetry is there. Make sense?